My name is Ashish Jain, this time with much more voice. I run product management for identity at VMware, and I have also been working with the NAPS working group. And I just met Adam, the previous speaker, and I like him already because A, he's implementing NAPS, and B, he dislikes or disagrees with Brian. So they are both kind of positive points in my book. One thing which this audience may not know is that VMware also bought a company in the mobility space called AirWatch. So when we look at the NAPS, we also get some feedback from the device management point of view in addition to the identity point of view. So I want to spend some time with you today to kind of share some of that feedback. And I know we only have about 20, 25 minutes, and I have a lot of content to cover, so I'll try to be on time. And this is the last session before lunch, so things may get exciting towards the end, and I'll try to keep us on time. So at a broad level, the things I want to cover with you today: why this is important, what is the experience today, where do you want to get to, what's the challenge, and if you have to go back today, back to your enterprises, what are the options that you have available to you? In terms of why this is important, so 3-4 years ago, if I start the same conversation, I'll ask by, raise your hands, how many of you have a smartphone or a tablet? Today, that point is completely irrelevant because all of you have smartphones and tablets. Irrespective of what report or data or statistic that you pick up, you will realize that more and more enterprises are using the mobile devices. So if you look at the numbers, about 89% of the employees, that is essentially all of you, use a mobile device to access their corporate resource. In terms of the ratio, there is 40% of the mobile devices as compared to the 51% of the laptops. And that number used to be 3 years ago, 80% laptops and 20% mobile devices. In terms of the application, there is 4 mobile applications being written as compared to a one PC or a native PC application today in the enterprise. And when we look at the adoption of the tablets, this is a picture which shows that the enterprises are willing to buy 21% of the tablets today, and that number changes to 51% into 1 year. So that kind of gives you a picture that the bottom line is that there are more mobile devices entering the workplace, and the second thing is that more and more employees are using their devices to access the corporate data. So this goes back to, I think we discussed that earlier today in the keynote, and Andre mentioned it, the borderless identity. That the fact that you can't have an iPhone bring into your corporate, connect to a blue cable, and then have access, which is why identity is more important. On that point, even the Mac doesn't have an Ethernet port, but that's a separate discussion. So where do we go from here? The experience, and Brian walked you through the step-by-step why he's late in filing his expense report, so I won't go into details of that one. But at a high level, if you think about it, any application that you use today on my device, the experience that I go through every day is I click on the mobile application, I enter the server information, which does discovery and tenant check and so forth. Then I get redirected a couple of times. I enter my login information, and then I have, again, a few redirects, and then I have access. I have more or less the same experience if I access a web application on my device, where I type in the URL of the service, I get redirected, I authenticate again, and then I have again redirected, and then I have access. And if any of the application that you're trying to access is behind the firewall, or if any of the API that you're trying to access is behind the firewall, then you also need to have a VPN session, which basically means starting a VPN client, which also means entering a second form of authentication, secure ID in some cases. So all in all, the experience to access for 89% of you for that corporate data isn't where we want to get to. So if we switch back to, forget for a second all the technologies and forget for a second how the standards would come into play, where do I want to get to? What's the experience that each one of us would like to have when we access the corporate information? So I'm going to borrow the terms from the SAML word, the IDP init and the SP init. And as an end user, I want to be able to come in, take my mobile device, and either have an IDP flow where I see a place where all the applications and data entitled to me are available on a single screen, or I go to my Springboard where I see all the same applications that are entitled to me. And as an end user, I don't really want to care if this is a native app or this is a web app or this is a virtualized app. I want to be able to come to a place, look at my Springboard, click on the applications I want to access, and then have access single sign-on to each type of application. Now, many people in this room will probably care only for native and the web application, but from a VMware perspective, we also do a lot of work for virtualized Windows application. So when I look at, as an employee, in order to do your job on a mobile device that all of you have, I want to be able to give you an access to all different types of applications. Now, that's not to say they should be all seamless. We talked about dynamic trust. We talked about adaptive authentication. So there may be cases when I click on an ADP or I click on a more sensitive application, I may be challenged for an additional type of authentication. But by and large, for majority of the applications, this is the experience and this is the behavior that I think we want to get to. So what's the challenge? So where we are today as an industry, I'm going to change gears a little bit and talk about from a spec perspective where we are. The more common flow for when you look at Salesforce and Concur and Box and Workday, the more common flow most of us have deployed the applications is this. The user accesses a mobile app. It goes make a request for an access token, and I'm combining the resource server and the AS into this picture. You get redirected to an IDP, which goes back to an AD where you authenticate. You come back with a SAML assertion, and then the AS gives back an access token, and the native app uses the access token to make an API call to have access to the data. This is by and large a common flow that all of us deploy. Now, multiply that by the 30 applications that you have in your mobile device, and this is where you're going to do that over and over and again. The challenge with this approach is, I think we mentioned in the previous 2 sessions that I have to do this every time on every login app because most of these applications don't have a way to manage state across different applications. The second issue is the moment I disable your access in AD, there is no way for a mobile applications to know that. We do block web access because all of that happens via SAML. However, there is no way when the AD to go and trigger the access token invalidation directly on the device. So it's up to the ISV to kind of have that hygiene and take care of that part. Now, even if the ISV has taken care of the access token invalidation, there is still sometimes an offline and cache data on the device. So even if you are an employee, you get disabled, the Salesforce and the Workday disable your access token, you still may have data residing on your device. Okay, so having said that, what are my options today? I want to spend the next 10 minutes to kind of walk you through what are the options available today as an industry, and each one of them have their pros and cons, and you may decide what may work best for you. The system browser, Brian talked about that. The flow is very similar to the previous picture where as an app user, I go to the mobile app, I go to the app server, the SAML flow happens, and I give the access token. The only difference is instead of a web view, now I use a system browser. Now the benefit is, of course, in this case, my credentials are not available to the native applications. As a user, I get to see the system browser and the address bar and the TLS and all that. However, on the downside, the experience isn't exactly perfect because you are on a native application and suddenly you flip to a browser view with a completely different brand look and feel. That's one issue. The second issue is that it does require code change. As of now, every public iTunes App Store application in the SaaS ISV world uses a web view. So there is some change required for those vendors to enable that. Third thing is the benefit is only there if everybody uses the system browser. If I only have one application using a system browser, and even if that maintains a state, there is no way for a web view to be able to share that state. The fourth challenge is that in the system browser, even though it maintains state, most IDP normally keeps an 8-hour session timeout. So the idea behind being able to log in once across different mobile applications using a system browser, it works, but at the same time, the chances are most likely you will end up typing your credentials at least once a day. The second flow is kind of enroll your device. This is where, so iOS has done a lot of work in terms of having a mature device management APIs. And Google at Work in the recent release has essentially kind of followed the same model. So today, when you bring in your device, you're able to register your device into your enterprise MDM server, which allows to apply a lot of policies like PIN code. In addition to that, you can also apply a cert to every device. Now, iOS 7 has a new profile for Kerberos, which hasn't really been used very much, But the way the flow works is, as an end user, I go to the mobile application goes to the app server, it does a SAML redirect. In this case, the IDP actually is configured to accept curb. So it sends a 401 negotiate back to the device. The iOS actually captures that request, and in some cases, if the KDC is behind the firewall, iOS can also trigger an on-demand VPN session. It reaches out to the KDC, gets the service ticket, passes it back to the IDP, which essentially goes back to the app server with the SAML assertion, and then you have the access token. So from an end user perspective, I'm able to come in, click on a link within the embedded web view, bunch of redirects happen, but I never flip, I never lose context, and behind the scene, all the curb magic between the iOS layer and the KDC happen, and I have access. Now, the benefit of this approach is, like I said, there is no flip, so the best user experience is pretty secure because you have a cert deployed on your device by the MDM server, and there is no code change required for the application developer. So you can use today with Salesforce and Workday and so forth. Now, on the con side, it does require that you enroll your device. And the same flow more or less work in the Android world, except instead of a curb handshake, you have to use the cert to give to the IDP. And there's a session by Andy from a Google at Work team to kind of talk about more tomorrow. The third flow I want to talk about, I couldn't find a name for it. I have seen that implemented in a few places, so I call it JavaScript Trickery. And the way the flow works is the first few steps are the same. The fourth step is, instead of the IDP authenticating, IDP actually takes the request, holds it, and makes an API call back through the user agent onto the same device, and then figures out if the user has already authenticated on that device. And if that's the case, it picks up the token, comes back to the IDP, and sends the assertion all the way back. So the benefit of this approach, again, is there is no code change required. You need an IDP agent as a user to install on your device. There is a flip involved, because when in the number 5 step, the IDP makes an API call to the token agent, it needs to get that application in the foreground. The downside of this flow is, and we have been testing, and by the way, all the flows I'm going to talk about 6 or 7, we have them deployed and tested in our lab. So if you're looking for more details, or if you want to play around with me, just going to reach out and we can have a session. So the flow in this case, the only challenge is when we test with a variety of the public iTunes App Store applications, it works about 70% of all of them. So even though there is no code change, it works both on iOS and Android. It still doesn't have the wide adoption across the application, especially because it kind of relies on how the OAuth implementation has been done in between the native app and the backend server. So it wouldn't be complete till I kind of mentioned Windows 10. So Windows 10 has a new concept they're introducing. It's called as Web Account Manager. Web Account Manager is a component which will be built as part of the Windows 10, and then they're allowing the IDPs to have a separate token agent equivalent component called as the Web Account Provider. So in this case, the way the flow works is the mobile application talks to the Windows Account Manager. Windows Account Manager takes care of the discovery part, redirects that to a Windows Account Provider, which, if you think about it, is the IDP proxy. The Windows Account Provider talks to the IDP, do the handshake, do the authentication, and gives back the token to the mobile app, which can then go back to the app server. Now, one of the things which is not mentioned here is that the Web Account Provider actually also has access to the browser's cookie stores. So the experience of the end user, that once I go and authenticate for a native application, the Web Account Provider can create an IDP session cookie for all the browsers. So on the same device, as a user, if I open a browser and I get redirected to the IDP, I'm already authenticated. So the experience for an end user, that on a device, whether you access a native application or you access a web application, you're always single signed on, is pretty cool. The second flow, which I'm not showing here, is just like the way the previous screen showed the JavaScript Trickery, Windows 10 also has a way not only for a Web Account Provider to talk to the IDP, it also has a back channel for the IDP to talk to the Web Account Provider. So this flow can technically be used both for a system browser as well as the web view flow. Now, the challenge with this approach is, how many of you have Windows 10 or Windows devices? Don't answer that. I know the answer. But the challenge is Windows 10 is still not shipped, and it will still take some time before we get this adoption. But it's encouraging to see that when Windows 10 comes out, they are taking this issue of mobile access to web and native applications pretty seriously. Okay, this kind of brings to the last item about NAPS. What NAPS did is we kind of took into all the accounts of all the different flows across all the devices. And if we can, similar to the SAML standard, can have a similar way built on top of OpenID Connect so that we can go to the ISVs with a very singular interface and a singular voice by saying every IDP will implement it. And the flow it works is that the mobile application talks to the token agent, and you will realize the similarities between this and the Windows implementation and the JavaScript trickery I showed you before. The token agent talks to the IDP. The IDP then goes back to authenticate to the AD, the standard flow. And in this case, the token agent gets its own access token and refresh token. And then after that, the number 5 step is when the token agent uses its own access token to go back and get what we call the AC/DC token for the target application. So from a native application perspective, all he needs to do is the discovery to figure out which token agent to talk to, and then the token agent takes care of getting the right AC/DC, and then there is no change on the native application, and the backend application can just use to acknowledge that AC/DC token to give you back the access token back to the mobile app. So in generally, like I said, the idea behind NAPS is to take care of all the previous learnings across the different platforms and then see if we can have a single API and a single interface across all the applications. So if I have to summarize all the things, whenever we talk about when we have too many options, then it goes back to everything is amazing, but nobody's happy. So I kind of feel like that's the state we are in. We do have too many options. Some of them can be implemented today. Some of them will depend upon what's the state of your enterprise. Some of this will depend if you are an app developer yourself or you're looking to consume Salesforce and Workday in your enterprise. So if I have to kind of put that into one slide, this is the option that we discussed today. If you use the system browser, there's a minimal code change, but it's available now that you can use. If you use the enroll your device option, there is no code change required. In my perspective, this is the best experience available today. At the same time, it does require MDM enrollment. If you use the JavaScript trickery, there is no code change required, but in our testing, we have found that only a limited number of applications are able to support it. And if you're only using those applications, this may be the right way for you to go to. The vendor SDK, I did not cover it, but there is definitely a certain vendor-specific SDKs. And the two challenges with this approach is, one, there's a vendor lock-in, and the second challenge is it only works for the enterprise in-house developed apps, because the chances that the public applications like Box and Salesforce would embed a proprietary SDK is pretty minimal. So if you're looking for only enterprise in-house apps, this may be the route that you may want to evaluate. Windows 10, I'm very impressed with what has come so far, but it is platform specific, and it's not there today. So the challenge with this is, as an application developer, if you are writing an application, you have to say, OK, in Windows 10, I'm going to do this. And in iOS, I'm going to do this. In Android, I'm going to do this. So the testing and troubleshooting and all that maintenance is kind of challenging. The NAPS flow, I think we talked about it. It is cross-platform, which is the beauty of it. It is also an open standard. And I think as of last week, we do have a draft version. And if John Bradley would complete that, and we will have an implementer's draft call to action for John. And then it is still in the spec state, but at the same time, I think we are very, very close, which is why I'm happy that Adam actually have a live implementation working on it. I think this is about the end of my presentation, and I'm here for questions. Thank you.
Thank you, Ashish. You remind me of my wife sometimes. If only John would
I don't
do
want to
it
take
on
that
time.
comment. I don't know.
Only John.
Are we recording this session or no? Because we shouldn't record this part.
That's okay. She knows. So questions?
how do you troubleshoot these things? You showed a lot of flows in there, and they're all kind of in the apps or at the IDP or the service provider. Thoughts on troubleshooting?
So I think this goes back to how do you troubleshoot if you have a TCP/IP challenge. I think if you do our job right, then I think all the OAuth magic and all the SAML flow magic should be enough like a dial tone, and we don't have to troubleshoot it. As we continue to evolve it, like for instance, SAML in the 10 years ago, every time you go to a SAML implementation, you have to troubleshoot it. Today, I don't see that discussions anymore. OAuth and OpenID Connect, we are still there. This is why we have a certification program that OIDF launched. But if you look into it from a SAML perspective, we had something similar by Liberty Alliance 10 years ago. It doesn't exist anymore. Because I think over a period of time, we mature the standards enough that we don't need a certification program. So to answer your question, part of this is leveraging the protocols that we have developed over the last 15 years. Some of them are more mature, so we can use them as it is. Some of them will take a couple of years to get to a point where troubleshooting isn't really a question anymore. But till that time, you and I, we're going to have to figure out a way to test it.
I'll try to speak very loud. Okay. So NAPS addresses authentication between native app using the browser quite well, right? So it describes it quite well. How about single sign-on between two native apps?
So the single sign-on in between two native applications, the way it should work is, one of the biggest challenge on a mobile device is that as a browser web SSO flows completely work, we don't have a way to maintain a state on a device. What NAPS does is introduce the concept of a token agent as an IDP proxy which can maintain that state. So when, in the same flow, when the second application has to reach out, it's going to reach out to the token agent. Token agent would have already maintained its own access token. He's already done the authentication. So in that case, all it will do is, the experience for the second app would be, you click on the app, you do a flip on an iOS, not on the Android. You come to the token agent. Token agent will say, you already authenticated 10 minutes ago, and gives back the AC/DC token, right?
And on Android?
On Android, there is no flip. The API and the flow is the same, except the token agent doesn't have to come in the foreground, right? But then you get the SSO experience because the challenge happens at the token agent level and not at the native application level. This also goes back to the point earlier that all the other strong auth, like FIDO and everything else, they only need to be implemented at the token agent level and not on a per app basis.
More questions?
Thanks. I guess I'm interested in understanding out of those flows that you presented. It feels like NAPS is kind of the futuristic one that's a little bit too early to adopt, but out of the others, if we were to adopt one of the others, which one would map most closely onto NAPS to kind of minimize the diff when NAPS matures? If that makes sense?
Yeah. So I think the question is, if we have to start today, which way should we go? So I think that my point is that all of them have different pros and cons, and it's completely not kind of apples and oranges, because going forward, if you look into 3 of those 6 flows, we need to have a concept of a token agent on the device. Whether that's a Windows token agent, in the JavaScript Trickery I showed you, there is an IDP agent which is installed on the device, same thing as the NAPS. So going forward, I feel like we would have something to maintain state on the device. And even if you look into the vendor SDKs, they kind of follow the same pattern. So if you are writing your own applications today, then, and if you have like variety of them, then the system browser would work. If you are a consumer of the application, then the MDM enrollment process would actually work today. And I think if you are about to kind of figure out in a year from now, where should I go, then look for your IDP vendor to figure out they have a native device presence, which eventually would evolve into a NAPS token agent.